Okay, hello there guys, welcome back to another LibGDX video tutorial. So in the previous video we managed to work on the camera and improve the way rendering happens. Okay, so we don't have to render things twice. We render once and this gets mapped to the physical display right away using the camera here. However, it seems that we had an issue with the with the improved collision detection. So I worked on that and fixed it. So what did we do, or what did I do to fix that thing? So let me show you here what changed. Okay, so first not the update, let me show you the code for our sprite colliding. So we are calculating now instead of checking on a square, I am checking the distance between the center of two objects. So here I am calculating delta x, delta y, the law of the distance, that the square root of squared of delta x and square of delta y. And if the distance is greater than the summation of half-width of the two sprites, okay, if it's greater than, they are far away, usually they are not colliding, so return false. Otherwise we will go into the next step where we think that they are colliding, so we have to check on pixel by pixel basis. So now I start rendering into collision display 1 surface. I clear everything, but I am setting everything to 0, and I start a new sprite batch, and I use the blend function here, which tells OpenGL how to combine two services. So this represents the source service, this represents the destination service. So I want to add the pixels of the destination into I want to add pixels into the destination surface, and the subtraction here, since we cleared this to zeros to my understanding, then nothing will be subtracted from that. Okay, and we render that. I get the image and I do the same thing here. Now as an effect of that, basically what happens is, if you get a pixel, you will have the color anything other than 0, and the reason for that is because we cleared this to 0 and we are adding the pixels of the new sprite onto the service, if that makes sense. So here if we have a look, we are getting the pixels from the two surfaces, and I'm checking if both they are not 0, just to turn it true, there's a collision, and it is as simple as that. No problem there. Okay, so this is it. Not very complicated, very straightforward. Yeah, not much there. So I want to also show you that it is working as well. So let me show you where is the stage. Okay. And so here I change this to 0, and I'm gonna show you the game. Just give it a second to compile and build things. Sorry. Sorry about that again. Anyway. Okay. So we start the game here. So now it is working. Now let me touch this by the side. Okay, as you can see by the side, and here we get too close, but you know, we didn't get a collision here. Okay, so that makes sense, that is okay, no problem. As you can see, we are getting too close, but our spaceship is not being destroyed, and the enemy is not being destroyed until they touch you. So it is working fine. Now this is the first improvement. The next improvement is that we made some changes to the stage management. So now when we are loading file, we could check few other things. So let me show you here. If we go to assets and go to stage 1. Now I improved stage 1 here, so I made an enemy appears here first. After that, after some time, another one appears here, then one closer, then one closer, so that the player knows that there are enemies coming. And then I grouped them, and then I made a wave. Okay, so something like that, little by little. So this one is very straightforward. However, if you look carefully at the file, you will find that now I have x equal r and d. So I have to make the game understand that when I say r and d, I mean by this select a random x location or select a random y location. So here this is represent a random x location. So if we go to stage management, first I created this one, this function which is parse float or rand. So I pass a string. If the string equals rand, I return a random number. Otherwise, I parse the float number and return it. So in the stage load here, the previous code was saying that if I have something like x equals, I used to say float.parse. Now here parse float or rand instead, and I pass the value without x equal or y equal and so on, and it works fine without a problem. That's because you know, we are just replacing the way, you know, the parsing part, and yeah, that's it. So very straightforward. This is the first change. The next change that I did is that, let me show you, which is, where is it? Not the shot, but management, no. Motion plan. The motion plan, if you remember, we pass a path to the game and it get you know, parsed. So I did the same thing here. So if I get the value of x and y, I check if it is the word rand. If it is so, I get a random number. Otherwise, I make you know, I parse it as a float, and same goes here. So now this is very straightforward. We can give random numbers for the enemies. Okay, and the last thing I created was adding a green enemy. Now the green enemy is straightforward here. Let me show you the sprite sheet here, and let me zoom a little. So I created this one. It's a modification of this one, this red one. Okay, I created this one here. So sorry. So all I had to do, I added a number of variables to make it oscillate while it moves. So here I added a shift value, max shift and directional shift. Okay, I'll show you how I'm using these in a second. So here I define the texture, I define the main variables. Okay, and yeah, And also I set the attack of this enemy to be 2, so it's stronger than the previous one. And also added a variable max angle, which represents the max angle it can turn per second. Okay, and that's it. Now in the update, I am calling the original update of the basic class, but before that I am checking the shift value. Okay, and I am adding to that the shift direction multiplying the maximum shift by time, meaning that it will, let's say if this value is positive, it will keep moving, let's say, to the right. When it is beyond a specific point, the shift value gets to the shift direction gets to the it becomes negative, so the direction now is towards left. And when it goes in beyond the negative max shift value, the shift direction goes to the right, so it keeps oscillating. Now this shift value is going to be added to the x and y using the angle plus 90 degrees, because if I say using the angle only, it will push our spaceship forward, but I wanted to move left and right. I wanted to oscillate left and right. Because of that, I am adding 90 degrees. So 90 degrees is actually perpendicular to the y-axis, which is the x-axis, if that makes sense. And I update, and that's it. So let me show you the final result of all of this. So now we run the game. Okay, and by the way, the code of this spaceship is 1. I mean in the file. So let me just show you that quickly. So here we have enemy 1, enemy 1, enemy 1, as you can see here. Okay, if that makes sense. So let's start this. Okay. Okay, so I'm trying to kill everyone so that okay. So those enemies appear at random X location, goes towards the center, so that the player knows to avoid them, or learns to avoid them. And the next group goes towards this point. The last group will go to here. This is all part of the first wave. Good. Now this is the second wave. Good. And another wave. Good. Okay, now this is the third wave. Now check this out. Okay, this is the wiggle I was telling you about. Okay, so I will make it visible a little bit more. So first, instead of this, I'll change the stage to be stage 2, meaning that start from the one after that, if that makes sense to you guys. And also I'll go to here and I will change this. I'll make this 0.5, 0.5, so it should go towards the center of the screen, just to show you how it moves. Go. As you can see now. Okay, I think it went beyond, and also it is a little bit too fast, if that makes sense. So I'll change this to 100, so it's a little bit slower. Maybe I should create one enemy instead of bunch. So we run this now. Okay, so now it's moving. As you can see, it's oscillating in the X direction. Okay. So now it's trying to reach on the center. Okay, so it'll keep doing that forever. Right? So very interesting behavior we got here because of what we did. Yeah. But anyway, the point is this should be a little bit harder to kill because of the wiggling, and also a little bit more dangerous because it could actually destroy your spaceship. Okay. And it could touch you because of its maneuvers. So yeah, so these are basically the changes that I did to the game, and now it's the game is much more suitable, for building stages. We fixed, I think, most of the issues, and yeah, that will be all for today. Not much programming happened here. We just, discussed this new enemy, and that's it. Maybe I change this just to make it 30. Oops. Just a test to reduce the wiggle there, but later on in the next video I'll start working on the next wave, and we will improve this one, and basically I'll start making ones that attack you. So now we reduce the wiggle. Okay, so it is a little bit better. Okay, so it's trying to go here, and it will keep doing that. Yeah, and if you want to avoid all the wiggles, you could just say make this, let's say, 1 max shift, which will mean that the maximum value for the wiggle is 1 unit, so it will be not visible at all, and it will behave almost normally, almost. Okay, and now it will keep trying to reach that point, so it will keep rotating and rotating and rotating. Okay, so that's it. That is all for today. I'll put this back to the value maybe 60 as it was. I will save that, and let me go to stage 3. I will undo these changes. Okay, so this is the original one without problem. Save that, and yeah, so that's all for today, and hopefully in the next video we will improve our enemy and see what we could do. Thank you for watching, and have a nice day. Bye bye.